Hello everyone. In the beginning of the class, let us see new announcements. Okay, the first new announcement is May 17th, 2022. Class videos uploaded. Hello everyone. I have uploaded class videos of May 17th, 2022 to YouTube. Their URLs are this, and this. Best regards, Wei Zhen. The second new announcement is the handout of Chapter 2 has been updated. Version 2022-0519. Hello everyone, I have uploaded the latest version of the handout of Chapter 2 to eCourse 2 website. The location and the file name are eCourse 2 website, wireless communications and machine learning. Course content, handouts, Chapter 2, handout 2022-0519.pdf. Best regards, Wei Zhen. Okay, next let us look at the progress of the last class. Okay. In the last class, we have taught to Chapter 2, handout, page 47, problem 48, solution, equation 1, unfinished. Okay, let us look at the blackboard. Okay, because I do not have a blackboard with me now, so I use the Microsoft Word instead. Okay, we are talking about Chapter 2, page 47, problem 48, derive equation 60. Okay, what is equation 60? Okay, let us look at the handout. Okay, to minimize the sum, okay, let me make this larger. Okay. To minimize the sum of squares of Ri, where Ri is the residue, the gradient equation is set to 0 and solved for delta beta j. Okay, what is delta beta j? Let us review it. Okay, delta beta j first appears in equation 57. Okay, so the vector of increments delta beta j is called the shift vector. Okay, so -2 summation I is equal to 1 to n capital Jij. Okay, what is capital Jij? Okay, let us review it. Okay, capital Jij is equal to partial f of xi beta over partial of partial beta j. Okay, and fxi and beta j, we have already introduced them. Okay, if you forget, please review the videos of the previous classes. Okay, times delta yi minus summation k is equal to 1 to m. Capital Jik delta beta k is equal to 0. Okay, what is delta yi? Okay, let us see. Okay, delta yi is equal to yi minus fk of xi beta. Okay, let us go back to the blackboard. Solution according to equation 49. Okay, let us see equation 49. Okay. So the least squares method finds the optimal parameter values by minimizing the sum of squared residuals s. S is equal to summation I is equal to 1 to n Ri squared. Okay. The sum of squared residuals is S is equal to summation I is equal to 1 to n Ri squared. Okay, this is equation 1. Okay, good. Okay, then according to equation 59. Okay, let us see equation 59. Excuse me. Okay, equation 59 is this equation. We have talked about this in the last class. So Ri, it is the ith residual, is equal to delta yi minus summation k is equal to 1 to m, and capital J ik delta beta k, like this. K should be italic, and this m should also be italic. So this is equation 2. To minimize S, the gradient equation is set to 0 and solved for delta beta J. So it means that the gradient of S is equal to a 0 vector. S should be italic and the vector should be bold. So this is equation 3. So gradient of S is equal to 0. According to the definition of gradient, so gradient is equal to a vector. I need brackets. Brackets and 3 boxes. So the first element is a fraction, and it is partial S over partial delta beta 1. Oh, okay, partial S over partial delta beta 1, and vertical dots, and the last element is okay, partial S over partial delta beta M, which is equal to a 0 vector. Okay, so we can see that the gradient S is M is an M by 1 vector. Okay, and this is equation 4. Okay, where for J is equal to 1 to M. Okay, so now we need to find the partial derivative. Okay, this partial S over partial delta beta J. Okay, which is equal to partial over partial delta beta J and summation this term. Okay, S is equal to this term. Okay, let me select it. Okay. And it is equal to okay, partial over partial delta beta J and summation okay, Ri squared, and Ri is equal to this term. Oops. Okay, delta Yi minus this summation. Okay, so let me add a parenthesis here. Okay, and this term square. Okay, good. Okay, next, because the partial derivative is a linear operator, so we can move partial over partial delta beta J into the summation. Okay, so like this. Okay, we move this term, partial over partial delta beta J into the summation. Okay, like this. Okay, so it is equal to, okay, let me copy this. Okay, partial over partial x f of x square. Okay, so according to the chain rule, okay, it is equal to, okay, 2 times delta yi minus summation k is equal to 1 to m. Capital JIK delta beta k, and the square disappears. And according to the chain rule, we need to take the partial derivative. Okay, here. Okay, partial over partial delta beta j, and this term. Okay. Okay, so next, okay, let us copy this again. Okay, and this term take partial derivative to delta beta j. Okay, so delta yi can be treated as a constant, so it disappears, and minus summation k is equal to 1 to m capital JIK delta beta k. So the only term in this summation that contains delta beta j is capital Jij delta beta j. Okay, so after taking the partial derivative, the remaining term is, okay, so the summation disappeared. Okay, so after take the partial derivative, we will have this. Okay, capital Jij okay, and this term partial disappear. Okay, good. Okay, this is the minus sign. Okay. Okay, and J should be not bold and italic. Okay, good. Okay, so next, it is equal to, okay, we can move the negative sign and the constant 2 out of the summation. So it is equal to negative 2. Okay, it should be the negative sign. Okay, and summation. Okay, and the 2 is just be moved out. Okay, and Jij, we can move it in front of this term. Okay, so finally we will have this negative 2 times summation I is equal to 1 to n capital Jij times delta yi minus summation k is equal to 1 to m capital JIK delta beta k. So let me align at the equality sign. Okay, good. Okay, so this partial derivative should be equal to 0. Okay, so this is equal to 0. Okay, good. Oops. Okay, and let me align at the equality sign. Okay, and this is equation 5. Okay. Oops. Okay, the format changes. Okay, so I think I do not use this here. Okay, I use a text box instead. Okay, a text box. Text box. Text box. Okay, and equation 5. Okay, and okay, should be 12, and the font is Cambria Mass. Okay, and align to the right and the friend should be none. Okay, and align to the right. Okay, like this. Okay, good. Okay, so this complete the derivation of equation 60. Okay, do you have any questions? Okay, align right. Okay, good. Okay, let us go back to the handout. Okay, so we have just derived equation 60. Okay. Which on rearrangement become m simultaneous linear equations? The normal equations. Okay. We can see that after some rearrangement, okay, summation I is equal to 1 to n, okay, moves here. And here is the summation k is equal to 1 to m, okay, moves here. And okay, and capital capital Jij moves here, and capital Jik is moved here, and the delta beta k is moved here. Okay, and then summation I is equal to 1 to n is moved here, and the capital Jij is moved here, and the delta Yi is moved here. Okay, so it is very easy to get equation 61, where J is equal to 1 to m. Okay, the normal equations are written in matrix notation as, okay, let us see, J transpose times J times delta beta is equal to J transpose delta Y. Okay, this is equation 62. Okay, then how to derive this equation? Okay, let us see the blackboard. Okay, because I do not have a blackboard with me now, so I use the Microsoft Word instead. Okay, so now we are in chapter 2. Okay, let me change the font size to 12. And page 47. And this is problem 49. Okay, so you can see that we have many problems on page 47. Okay, derive equation 62. Okay, solution. Oh, sorry. Okay, equation 61 can be rewritten as the following form. Okay, let us see equation 61. Okay, equation 61 is this equation. Okay, good. Okay, note that there are totally m equations here. Okay, so we can use write them into a vector form. Okay, like this. Okay, so I need brackets. Oh, sorry, I need brackets, not brackets. Okay, and insert 3 boxes. Okay, here. Okay, so first term should be, okay, this summation I is equal to 1 to n, summation k is equal to 1 to m, capital Jij, capital Jik, delta beta k. Okay, where J is equal to 1. Okay, so let me input, okay, summation It is 25 minutes. Let us take a break.